Okay, we're looking at torque practice problem number 3 here. This is the one with the horse. And for part A, we are trying to figure out the torque that is being produced by the pulling force of the horse. Horse. So that's this yellow line right here. What's that pulling force? So if we take a look at this, there's some things we can identify. Down here, this is our pivot P. And that means going from the pivot up to where this rope is attached, this is our moment arm. Now, from the start of the rod to the end of the rod or the pull, the entire length is 3.6 meters, and we go back a distance of 1.3 meters in order to get to this point here, which means our value of R is going to be 3.6 minus 1.3, or 2.3 meters. Our horse is also pulling this direction with a force equal to 2100 newtons. Remember, newtons in the metric is a unit of force. So we have R and we have F here, and as given by torque, as we've seen many times now, R cross F, these two vectors we're multiplying for the perpendicular direction, is RF times the sine of the angle theta. We've got two angles in this problem that are given to us. We've got a 35 and a 70 here. We're going to ignore the 70 for a little bit. It doesn't actually play into what we want. That's for part B. We want just the 35. Now, when we look at this 35, if we put in 35 for our angle of theta, this problem would not go well for us. What we need to do is what we've previously done. Let's redraw this picture and let's translate this force vector down to the pivot. I'm actually going to do this on the diagram, and I'm going to kind of do it in a neat way. So here's the pivot, nice and orange right there. And I'm just going to extend back this beam. Okay, so if I just take this beam and extend it backwards, that's the line of the beam. When I take my force vector and slide it down here now, like this is the force, I still have this angle right here. Notice the backtracking of the black line is parallel to the rod itself or the pole itself, and I have not rotated the force vector, which means this angle here is 35 degrees. I just kind of redrew the same picture above but down below. If I know that this is 35 degrees and I'm looking from R to F and I want this angle here in green, well, I know that going from this black line down below that I made to the rod itself, that was 180 degrees. I need to take off of it the 35. So 180 degrees minus the 35 degrees gives us the angle that we're looking for of 145 degrees. This is the angle we want in the problem. So that angle is a little hard to come by, a little hard to figure out if you're not doing a little bit of geometry there, but that's the angle we want. So our torque can finally just be R of 2.3 times the force of 2100 times the sine of 145 degrees. Throw that all into the calculator. 2.3 times 2100 times the sine of 145. We get 2770 and some decimals that we're going to ignore. And our units there are newtons for a force and meter. And there it is. If we want to get a direction of this torque, let's take a look at what's going on here. The horse is pulling this, so it's going to rotate this direction. That is counterclockwise, thinking about a clock, and mathematically we call a counterclockwise direction positive. If we take our four fingers and rotate them in that counterclockwise direction, just kind of following how that beam would rotate, our thumb points out of the screen, or if we're looking at a sheet of paper, it points out of the paper, so our direction is out. So we've got an outward direction of the torque, which is positive, and that is counterclockwise. So there we go. Quick little torque problem, nothing too crazy. Hard part here was trying to figure out what that angle in green was. Little bit of geometry needed in order to find it, but not too bad. Hopefully you got that. If you didn't, hit me up and take a look at the next problem. Adios.